Here we have fx is equal to 1 over x squared. In order to apply the rule properly, we need to rewrite the fraction. So I write it as fx is equals to x to the power of negative 2. Remember, in previous grades we learned if we move the denominator to the numerator that we change the sign of the exponent. Now that I got rid of the fraction and I have a simple expression with x as the base, I can apply the same rule as in the previous lesson. So to find the first derivative, I multiply whatever is in front of x with the exponent of negative 2. So I have negative 2. And in the exponent, I have x to the power of negative 2 minus 1. If I simplify it, I have negative 2 times x to the power of negative 3. And you can rewrite it in the same way as you found it. So it's negative 2 over x to the power of 3. So I leave my answer in positive exponents. It is important to note that I first get rid of the fraction with x in the denominator. And once I have rewritten fx, where x is now the base, I can apply the same rule as in the previous lesson. In our second example, we have y is equals to 4x to the power of 5. I cannot differentiate yet or apply the rule because I have x to the power of 5 in the denominator. So I'm going to rewrite it. Y is equals to 4 times x to the power of negative 5. Notice the sign of the exponent has changed. Now I can apply the rule that we learned in the previous lesson. So the first derivative is dy dx, and that is equal to 4 times negative 5 from the exponent, and I subtract 1 from the exponent. If I simplify it, I have negative 20 x to the power of negative 6. And we want to get into the good habit of writing the negative exponent as a positive exponent. So leave your answer as positive exponents. In our third example, we have dx, and the expression that we want to differentiate is x cubed over 4x to the power of 7. Now let us apply the rules of dividing which we have learned in grade 9. So in grade 9, we have learned to subtract 7 from 3. So 3 minus 7 is x to the power of negative 4 over 4. So to differentiate, it's negative 4, x to the power of negative 4 minus 1 over 4. The 4's will cancel each other out, and I have x to the power of negative 5. And we want to get into the good habit of leaving our answer in positive exponents. So it's negative 1 over x to the power of 5. Let us move on to roots. Fx is equal to the square root of x. I can rewrite the square root of x as x to the power of a half. Now that I have x as the base, I can find the first derivative. So I multiply the exponent of a half with the value in front of x, which is 1. So it's a half times 1. X to the power of a half minus 1. So if I simplify, I have a half x to the power of negative a half, which can be written as 1 over 2 x to the power of a half, leaving our exponent as a positive value. You can also go further by taking the x to the power of a half and writing it as a square root. It's not always necessary, but it is good to practice these basic skills. Here we have y is equal to the cube root of 4x. Because we have multiplication in the root, we can expand it as the cube root of 4 times the cube root of x. In order to differentiate, I only need to rewrite the x. So the cube root of x becomes x to the power of a third. So the derivative of y is dy dx. I have the cube root of 4 times the exponent of x, which is a third. And in the exponent, I have 1 over 3 minus 1. I simply subtract 1 from the exponent. If I simplify, I have the cube root of 4 over 3 times x to the power of negative 2 over 3. And it's good practice to leave the exponent as a positive exponent. And you can also rewrite x to the power of 2 over 3 as the cube root of x squared.